Right now we are asked to find the integral of tan x to the fifth times secant x to the fourth. Now just from looking at this, we can see that tan x and secant x are functions that are very closely related to each other. We know that the derivative of tan x is secant squared x. So we might be able to use substitution to figure out this integral. And we know from our Pythagorean identity that cosine squared of x plus sine squared of x equals 1. So now if we divide both sides by cosine squared of x, then we get 1 plus sine over cosine is tangent, so we get tangent squared x equals 1 over cosine is secant, so we get secant squared of x. So if we have secant squared of x in here, we can replace it with a form of tangent x. And then if we use substitution, we can substitute u for tangent x, and du is going to be another secant squared x. So we can rewrite this integral as tan x to the fifth times secant squared x times secant squared x. And with our first squared, we're going to convert it into tangent, and our second squared we're going to use for our substitution. So we're going to first convert our square into tangent. So we have tan x to the fifth. This is 1 plus tan squared x times secant squared x dx. And now we do our substitution. Let u equal tan x. Du is going to equal secant squared x dx. And if we notice our integral, this term is the exact same as this term, so it can be replaced by du. And every tan x can be replaced by u. So we have successfully made a substitution. So we can rewrite this integral in terms of u. So we have u to the fifth times 1 plus u squared du. And this is considerably more simple than our first integral. So we can do this now. So if we just expand this, we have u to the fifth plus u to the seventh. This is with respect to u. And we can easily do this as 1 over 6 u to the sixth plus 1 over 8 u to the eighth plus c. And if we make our original substitution, u equals tan x, then what we will get is 1 over 6 tan x to the sixth plus 1 over 8 tan x to the eighth plus c. And this is the solution to our integral.